12 chemistry students. Today what we're going to continue to learn is a continuation of our previous video. We're going to talk about energy changes and not rates of reactions today, but this is our unit. I didn't finish this in the previous video, so what we're going to do is we're going to do Q equals mc delta T equations, which is the heat equation. We're going to learn how to calculate heat. A quick review: heat is the transfer of thermal energy from a warm object to a cooler object. When an object reacts, it can either be an endothermic or an exothermic reaction. When it's an exothermic reaction, the surroundings get hot. When it's an endothermic reaction, the surroundings get cool. It's basically the opposite what's happening inside the chemical system. So if we can measure the surroundings in what we call a isolated system, and I'm going to make a change to your previous note, it's not ideal system, it's an isolated system. If we can measure the amount of heat that's absorbed by the surroundings in an isolated system, then what we can do is we can determine the amount of energy that was released by the chemical system. So again, if that wasn't clear, the potential energy of the system, okay, which we are going to refer to as H, also known as enthalpy, is going to be equal to the amount of heat that's going to be released by or into the surroundings. So the chemical system, which we'll represent by H, or the change in chemical system potential energy, is going to be equal to the heat released into the surroundings. So how do we calculate the heat that is released into the surroundings? Well, it really depends on the substance that we're talking about. Now this is C, which is called the specific heat capacity. Okay, sometimes it's represented by C with the subscript S, and for water, for example, it's 4.18 joules per grams times degrees Celsius. So you have to look at the specific heat capacity table on page 301, which I'll give to you. But it means that it requires 4.18 joules to change 1 gram of water 1 degree Celsius. Now different substances have different specific heat capacities. So iron will have a different specific heat capacity than aluminum, and so on. And things that change temperature quickly generally have a very low specific heat capacity because they don't require a lot of energy to change. So M is the mass, and that's going to be in grams. So mass in grams. And T, delta T, is going to be the change in temperature, which is going to be calculated in degrees Celsius. Now when you multiply these three things together, if you look at the units, the Celsius will cancel out, the grams will cancel out, and you'll get your units in joules. I also want you to keep in mind that, so this is energy, or heat specifically, so heat energy. And it's measured in the units of joules, which is represented by a J. 1,000 joules is going to equal 1 kilojoule. So let's look at an example question. What is the heat transferred when you have 1 liter of water and its temperature is changed from 18 degrees Celsius to 100 degrees Celsius? Well, it's asking us for heat, so that's Q. And if we want to know Q, we know that Q equals mc delta T. We know heat, so if we want to figure out the heat of anything, we have to know the specific heat capacity of it. The specific heat capacity of water is 4.18 joules times grams to degrees Celsius. Now some of you guys are like, where did you get that, sir? Well, I got it from a table. You guys are going to remember that water is going to have that, but you can always ask for a table if you need the specific heat capacity of a substance. And since we're talking about water, we know it's 4.18. So our mass in this example as well, let's take a look and write down our variable. Our mass, oh, don't know it. Oops, no, sorry guys. Temperature, you can take a look. I have a final temperature, which I'll go TF is 100 degrees Celsius, so the little F there, and TI, which is 18 degrees Celsius. You'll notice that this is change in temperature. So what is that change in temperature? Well, to find change in temperature, you have to take your final temperature and minus your initial temperature. In this case, it would be 100 minus 18, which is 82 degrees Celsius. So guess what? We got change in temperature, we got specific heat capacity, we don't know the mass. Another thing we got to know, is there a way we can convert liters into mass? Well, there is a way. V is volume. And we know that 1 liter is actually the same as 1,000 milliliters. You should know that off by heart. And the density of water is actually 1 gram per per 1 milliliter. This means if you know the volume, all you have to do to find the mass is change the number. I'll show you a little bit more complicated here. 1,000 milliliters times 1 gram over 1 milliliter. The milliliters will cancel out and we now know our mass. So it's 1,000 grams. So if we look at this, we now have every single thing we need to find heat. So Q, let's plug all our numbers in. Q equals 1,000 grams times the specific heat capacity, which we know of water is 4.18 joules, times grams times degrees Celsius times 82 degrees Celsius. When we multiply this out, we should have the correct unit cancellation, and we do. Grams, degrees Celsius, our units will be in joules. Let's do that calculation. The answer we get is 342,760 joules. Now, I never want you to leave a number that big. One thing we can do is we can convert this back to kilojoules. Now, if you remember, 1 kilojoule is equal to 1,000 joules. So what we're going to do is we're going to just do a little bit of unit cancellation here, times 1,000 joules on the bottom, 1 kilojoule on the top, and the answer we get is 342.76 kilojoules. And we can write a therefore statement. So therefore, the amount of heat that is transferred is 342.76 kilojoules when you transfer temperatures change from 18 to 100 degrees Celsius. So this heat is being added to the water to change the temperature. If we were just going to think about this reaction, this is getting hot, right? So because it's hot, and it's exothermic reaction. Okay, I'd like you to try this question. What is the final temperature if 300 joules of energy is transferred into 300 grams of ice, which has a specific heat capacity of 2.01 joules per gram times degrees Celsius at the initial temperature of negative 50 degrees Celsius? So you're changing the temperature of some ice now. So what I'm going to have you guys do is you're going to use this equation, Q equals MC delta T. Take a look at what you know. Range it, see if you can solve it on your own. I'll be looking for an answer on a multiple choice question here in a moment. That's it for today. Bye-bye.